Today we are going to discuss about assignment problem for the maximization case. We have already discussed assignment problem for the minimization case. So in this class we will discuss about maximization case. I have taken one example here and see how we are going to solve the problem. Let us start. I have taken this question for the maximization problem. Assign 5 jobs to 5 machines to maximize total expected profit. First step is that we have to convert the maximization problem into a minimization problem. So how we are going to convert the maximization problem into a minimization problem? We have to find the highest value in this matrix. So what is the highest cost or highest value in this matrix? If you see, we have to check each cell of the matrix and we can say that 14 is the highest value or the element in the matrix. So what we need to do? We need to actually subtract each cell from this highest value to make the matrix a minimization problem. We have to subtract the value of each cell from the highest element to make it a minimization problem. Let us do it. The highest element of this matrix is 14. So 14 minus 5 can write here 9. It is A, B, C, D, E. This is 1, 2, 3, 4 and 5. Then 14 minus 11 is 3. Then 14 minus 10 is 4, 2, 10. Then 14 minus 2 is 12, 10, 8, then 11, then 9. Here 11. Yes, 11, then 2, here 9, 0, then this one is 8, 8, 0, this is 10, 3, 7, then 7, sorry. Yes, 14 minus 7, 7, 9, 5, then 6, then 2, then 9. So this matrix is a reduced matrix. So this is a minimized matrix now. So we have converted the maximization matrix into a minimization assignment problem. Then the same procedure what we have done in our previous class for the minimization problem, we have to solve in that way. So we have applied our to get the solution of the minimization assignment problem. We have taken the Hungarian method or reduced matrix method or Flood's technique. Hungarian method is also known as reduced matrix method, also known as Flood's technique, which we have already discussed in our previous class. Okay, how we are going to proceed with this? Let us see. First step is that we have to check it is a balanced matrix or not. It is a balanced matrix, as we all know. then the number of rows is equal to number of columns. Next step is that we have to go for row reduction. So this is our row reduction. So to do the row reduction process, in each cell we have to search for the minimum value in the or the least value in the cell. So what I have to do? Let us see this. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. A, B, C, D and E. This is 1, 2, 3, 4, 5. Each row, first we need to check the minimum value and subtract that value from each cell. So if you see this row, in this row the minimum value is 2. So let us subtract this value from each cell. 9 minus 2 is 7. Then 3 minus 2 is 1. 4 minus 2, 2. Then 0, 8. Then for this row, it is 8. So subtract 4. 12 minus 8 is 4. Then 2. Then 0. Then 3. Then 1. Like this, for each row, we need to do it. Here, the least value is 0. So there will be no change for the entire row. So what do we need to write? We need to write the as it is. 9, 0 and 8. For this case also same, we are having 0. So no need to change. 8, 0, 10, 3 and 7. Check this last row. We are having the least or the minimum value 2. So subtract that value from each cell. 7 minus 2, 5. 5 minus 2, 3. 6 minus 2, 4. 2 minus 2, 0. 9 minus 2, 7. This is the row reduction. Let us go for the column reduction here. So for that I have to erase this one. Let us erase. This one is column reduction. This is A, B, C, D and E. This is 1, 2, 3, 4 and 5. For column reduction, we have to check each column. This method is called Hungarian method or reduced matrix method. So for each column, we need to check the minimum value. So for this column, if you see the minimum value is 4, so we can write 7 minus 4, 3. Then 4 minus 4, 0. Then 11 minus 4 is 7. 8 minus 4, 4. 5 minus 4, 1. As we are having 1 0 here, so there will be no change for this column B. It will be as it is 2, 2, 0, 3. The same for this case also, because we are having 1 0 here. 2, 0, 9, 10, 4. For these it is also the same thing, because we are having 3 0 here. 0, 3, 0, 3, 0. For these we need to change, because we are having the minimum value as 1. So 8 minus 1, 7, 1 minus 1, 0, then 8 minus 1, again 7, 7 minus 1, 6, 7 minus 1, 6. So this is our column reduction matrix. Now we need to assign for each cell, each row or each column, we need to assign one 0. So how we are going to do it? First we need to check each row, then each column. For a single 0, then we can go for multiple 0. What we can do? We can see first where we are having only one 0. For that we need to assign first. So what I need to do? Let us check this row. For this we are having one 0 here. Let us assign this one. If it is assigned, then we have to put a cross here. Okay. Then here 3 0, no need to do it. Here no, because it is crossed. For this we are having 1 0. We can assign 1 here. Okay. And after that, if we check for this column, we are having 1 0 here. We can do assign here and we can go for cross this. Okay. Well, how many assignments we need? Actually, we need 5 assignments, but here we got only 3. So, go for our iteration process. So, how we need to do it? We need to draw minimum number of lines to cross the 0, which will cover all our 0. We have to draw minimum number of lines which will cover all our 0. So, let us see how we are going to do it. So, if you see here we have maximum 0 here. So, we can put a line here like this. Then we can put another line here like this. Another line here we can draw to cover this 0 either this way or this way. Let us do it this way. So now we have 3 assignments and the minimum number of lines are also 3. So let us go for the further step. So what do we need to do for that? So we have got 3 assignments here. So we have drawn minimum number of lines. The minimum number of lines is also 3. So what is our next step? We have to check a minimum or least value for the uncovered cell. Those cells which are not covered by the lines, we have to check a minimum value or minimum cost. Here if you see, this is 3, 1, 2, 7, then 7, 2, 9, 7, then 1, 3, 4 and 6. So here the minimum value is 1. So let us see, we have to subtract this one from the uncovered cell and we have to add the value where there is a intersection between the line. What do we need to do? We need to find a least value or the minimum value for the uncovered cell and then we have to subtract that value from each cell which is not covered by the line and we need to add that value where there is an intersection between the lines. Let us do that. So if you see here the minimum value is 1. So what do we need to do? 3 minus 1, 2, 1 minus 1, 0, 2 minus 1, 1. Then here there will be no change where the line exists on the cell. There will be no change for the cell. So it will be as it is 0. Then this is 6. Now this will be as it is 0, 2, 0. This will be 4, then 0. Again 6, 1, 8, 0, 6. This one will be 4, 0, 10, 4, 0, 10. This one will be 4 as it is an intersection. The 3 plus 1 is 4. Then 6. Here 0, 2, 3, 0, then 5. Let us assign the 0 once again. So first we need to check each row and each column for a single 0. So if you see here 2 we are having, so leave it. Here 3, here 1. So we can put a assign here. But we need to cross this and this. Okay. Then the next step is we need to see each here. Here we are having 1, 0. Let us assign this one. Here also 1 because this is crossed. So we can go for assigning this one. If we will assign this one, then we can put a cross here. Right? So again need to check its column. Here we have assigned 1, so we need to cross this one. Here there will be no, so we can go for assigning this one. And for this it's done. For this it is crossed because we have already assigned this one. So if you see again we are getting 4 assignments, 1, 2, 3, 4, which is not a optimal solution. So the next iteration is needed here. So the same process we need to apply. We need to cover each 0 by line, putting lines. So how we need to draw it? So let us draw minimum number of lines like this. One will be like this, another one will be like this, and here one. So we have 4 assignments, 1, 2, 3, 4 and 4 lines also. So go for the third iteration. This is the second iteration, this is first iteration, this is the second one. Again we need to go for the third iteration. Let us go for doing the third one. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is our third iteration. This is A, B, C, D, E. 1, 2, 3, 4 and 5. The same thing we need to do here. We need to find a minimum value or minimum cost. So if you see for the uncovered cell 2, 1, 6 here 6, 4, 8, 10, 6, 6. So the minimum value is 1. So what we need to do? We need to subtract this value from each uncovered cell and we need to add it for the intersection cell. So 2 minus 1 is 1. Then there will be no change here. This is 0. This one 0. This is 5. Again this is 0. As this is the intersection of the lines, we can add here. Then 0. Then 5. Intersection is there. Then 0. Then what we need to do? We need to subtract this 1, then 7, then 0, then 5. Zero, 3, 0, 5, 0, then 5, 1, 7, 0, 5. Again this is 3, this is 0, this is 9, this one 4, this is 5. Again 0, this is a intersection 3, then 3, then there is an intersection, we can add 1 here, and this is 5. Let us assign again the 0. So if you check here 3, 0, no need to do it. Here also 3 in this row. In this row we are having 1, so first we assign this one. If we assign this one, we need to cross this one. For this case, we are having 1, 0 here, so let us assign this one. We need to cross this one. Here, if we see here also 1, 0. So we can assign and we have to cross this one. So we have checked each row. Let us check each column. Here we have done the assignment. Here also we have done the assignment. For this it is 2. For this it is, we have already assigned. For this we are having here 1. So we can assign this one and we can cross this one. Okay. So now only one assignment 0 left here. So we can go for assigning this one. So for this we got actually 5 assignments here. So now our process is completed. So this one will be our optimal solution. Let us calculate the cost. Actually this is a maximization problem. So we need to calculate the profit here. So how we are going to do it? Go to the table. So 1 is assigned to C. Let us write the optimal solution. Optimal solution. As 1 is assigned to C, then 2 is assigned to E, then 3 is assigned to D, then 4 is assigned to B, 5 is assigned to A. If you see here, the cost for the calculation of the profit, we need to go to the profit table matrix. So see, for C, it is the value 10. So 10 plus. Then the next value is 5. For E, it is 5. So this is our total profit. 10 plus 5 plus. For 3, it is D. D, we are having 14 plus. For 4, it is 14 plus. Plus for 5, it is 7. Let us calculate it. So it is 10 plus 5, 15. 15 plus 7 is 22. 22 plus 14. 22 plus 14. Okay, 22 plus 14 is 36. 36 plus 14, it is 50. So this is the answer of our maximization problem. So this is the answer for this assignment problem. I hope you understand the video. For the minimization case, please refer the previous videos. So don't forget to subscribe the channel and do share with your friends. Thank you so much.